Hello learners, let's continue our discussion with rocks and minerals. To begin with, we have here James Hutton, who developed the concept of the rock cycle in order to show how rocks and natural physical processes are interrelated or connected. Now, before we go into a deeper explanation of what is rock cycle, let us first define what is a mineral. Okay? Now, a mineral is a naturally occurring inorganic element or compound having an orderly internal structure and characteristic chemical composition, crystal form, and physical properties. Okay? Now, minerals combined with nature is the building blocks of rocks. Or in other words, mineral or minerals are the building blocks of rocks. Okay. Now, the question, what are the key identifiers or what are now the basis on how to identify minerals? So, we have criteria to follow or we have criteria of minerals. Number one, it must be solid. Okay? Mineral must be solid at room temperature. The second one, it is not man-made, meaning it is naturally occurring on Earth. The third one, it must be inorganic, meaning not coming from or not made from living things. Usually, minerals are inorganic, mostly. Alright? Number four, it has a fixed chemical formula. And number five, it has an orderly crystalline structure or atoms must be arranged in an orderly structure. Why? Because this contributes to the physical structure of a mineral. To show you an examples, we have here diamond for jewelry purposes. Next, we have fluorite, inclusion in toothpaste, talc, inclusion in baby powder, and we have selenite gypsum, which includes in walls in modern houses and in modern buildings. But before they come up with this result or this product, the main question now is how do minerals form? Okay, so there are two ways on how the minerals form. Number one, cooling of magma inside the earth, okay, from the mantle. In other words, crystallization through cooling of magma and lava. Okay? And the formation of crystals depend on the manner of cooling. If that is fast cooling, no crystals can be found. If that is medium cooling, small crystals. And if that is slow cooling, which is the ideal one, large crystals can be found. Again, crystallization through cooling of magma and lava. The second one, we have crystallization through solution, in which elements dissolved in liquid, usually water, and when these liquids cool to a solid state, they form now crystals. Again, how do minerals form? Number one, crystallization through cooling of magma. Second, crystallization through solution. Next, we have the group of minerals in which minerals are grouped according to the elements they are made of. I will not explain this one in detail. I will just present it to you. Okay? So example of group, we have beryl, calcite, and amethyst. Another groupings, we have silicates, which contain oxygen and silica, which is the most abundant group of minerals. Examples, we have mica and we also have quartz. Another, we have non-silicates, which make up only 5% of the Earth's crust, include some of the most important minerals. In example, iron, copper, and we also have gold. Next, we have native elements, which contain single elements. Very famous, we have diamond, silver, and we also have gold. Now, aside from the criteria I have mentioned a while ago, We have also physical properties of minerals which are helpful in order to identify the mineral. Okay? So the physical properties of minerals are used by mineralogists to help determine and identify a specimen. Some of the tests can be performed easily in the field, while others require laboratory equipment. We have color, luster, streak, hardness, cleavage, and fracture, and lastly, we have other properties. To begin with, let's have the color. Now, most minerals have a distinctive color that can be used for identification, and sometimes it can be misleading and can vary with the type of impurities. Okay, so remember, while color is an important property of a mineral, sometimes it can be misleading. Therefore, never rely on color in order to identify your mineral. Next, we have the streak. It refers to how light reflects off of the surface of a mineral, and it is referred to surface reflection. Okay? We have two types. If it is shiny like metal, that is considered as metallic, but if that is dull, non-shiny surface, that is non-metallic. The third one, we have luster. This is the color of the powdered form of the mineral, and the color of the streak can be different than the sample. As you can see, let's say for example, this is the mineral. Let's say this is color pink, and the powdered form looks like color white. Okay, again, the color of the streak can be different than the sample, and minerals must be softer than the streak plate. The fourth one, we have hardness. And hardness is one of the better properties of minerals to use for identifying a mineral. Hardness is a measure of the mineral's resistance to scratching. And we have here on the right side the Mohs scale. Now the Mohs scale is a set of 10 minerals whose hardness is known. Okay? The softest mineral we have here, talc, has a Mohs scale rating of 1, and diamond is the hardest mineral and has a rating of 10. Now through this, we can see if the mineral can stretch different objects just like human fingernail, copper, penny, glass, or steel file. The fifth one, we have cleavage and fracture. Now these two has something to do with on how the mineral breaks. When we say cleavage, the minerals break along smooth, flat surfaces, and every fragment has the same general shape. Take note of the word. If that is smooth and almost the same general shape, that is cleavage. If that is fracture, the minerals break at random with rough or jagged edges. Again, cleavage and fracture, the way the mineral breaks. If that is smooth, cleavage. If that is rough, fracture. Lastly, we have the other properties. It can be specific gravity, attraction to magnets, bending of light, reaction with hydrochloric acid, and smell and taste. Now, since you have already a good foundation of what is mineral, let's proceed now to the next topic, which is rock cycle. This is only continuation of our topic. Okay? Now, let's define first what is a rock. Now, we all know what rocks are, right? Now, they are lying on the ground everywhere. They are the mountains and canyons that you can't help but notice. We have all thrown them, sat on them, and dug them out of our gardens. However, to pin down an exact definition, that is something not all of us could do. Okay? Now, I will share with you a short or brief explanation of what is rock is all about. Okay? A rock is a solid mass of geological materials. Now, rock can be composed of only one type of geological material or mineral, but many are composed of several types. And speaking of rock types, we have here igneous rock. Okay? Now, how does igneous rock form? So it is formed from molten rock or magma in the subsurface or from lava extruded at the surface. So this is now the process in becoming an igneous rock. Now any existing rock such as igneous, metamorphic, or even sedimentary can be subjected to enough heat and or pressure causing it to melt. Now molten rock is called magma. Now when magma cools to a solid, it becomes an igneous rock. Okay? Now, the kind of igneous rock form depends on what was melted and how it was cooled. Now, igneous rocks are classified based on their mineral composition and texture. And we have the category of igneous. We have intrusive rocks and extrusive rocks. When we say intrusive rocks, cool beneath Earth's surface and it cool very slowly. Okay? Extrusive rocks cool on the Earth's surface and it cool relatively fast. To show you an example, under intrusive igneous rocks, we have granite, diorite, we also have gabbro. For extrusive igneous rocks, we have rhyolite, andesite, and we also have basalt. Next, we have sedimentary rock. Now, rocks are weathered, eroded, transported, deposited, and lithified in order to form sedimentary rock. Example of sedimentary rocks, we have clastic sedimentary rock. Okay, so these are made up of pieces of pre-existing rocks. Okay, pieces of rock are loosened by weathering and then transported to some basin or depression where sediment is trapped. Now, if the sediment is buried deeply, it becomes compacted and cemented, forming sedimentary rocks. Next, we have sedimentary rocks can also be crystalline, such as the crystalline limestone which precipitated directly from solution. Now, how does crystalline rock form? So basically, it refers to both igneous and metamorphic formation that consist of minerals that have formed by crystallization from a melt or solid state reaction at elevated pressure and temperatures. Lastly, we have the bioclastic sedimentary rocks, which is living things stuck together. Okay? Or the bioclastic sediments consist of biological material that mixed with other mineral particles and may contain various grain sizes. Okay? Example of that, we have coquina or shells of dead organisms. To give you another example, under sedimentary rocks, we have conglomerate, and the famous one, we have coal. Another rock type, we have metamorphic rock. Now, pressure, heat, and fluids cause pre-existing rocks or sediments to become metamorphic rocks. So this is now the process in becoming a metamorphic rock. Now, if the igneous rock basalt is exposed to sufficient heat and or pressure, it can be transformed into the metamorphic rock called metabasalt. Take note, when the prefix meta is applied to a rock name, that means that the original rock has been metamorphosed. Okay? Or that rock particularly exposed to high temperature or high heat. Okay? Or high pressure. Now, rocks that form from exposure to intense heat and pressure is known as metamorphic rock. Example, we have here the limestone. Once this limestone will undergo or will be exposed to high heat or high temperature and high pressure, so it will be metamorphosed. The result, now we have here the marble, which is an example of metamorphic rock. Now, to end my topic, the rock cycle does not go in just one direction. Any given rock can go through any part of the cycle any number of times. Example, the igneous rock will be exposed to pressure and heat. This become metamorphic. And this metamorphic rock, once this will undergo weathering, it becomes now sedimentary. For example, clastic sedimentary rock. And once the sedimentary rock will expose to melting, this become now igneous rock. So on and so forth. Again, any given rock can go through any part of the cycle any number of times. In which also James Hutton proved that the rock cycle shows interconnectedness, okay, or they are related with each other. That ends our topic for today. Thank you so much for listening.